Hey buddies, let's today start with the ninth chapter, that is data processing, organization, cleaning and validation. Let's start with 9.1. 9.1 talks about development of data processing. Let's understand what is data processing exactly. Processing of organizing, categorizing and manipulating data in order to extract information. So when you basically organize, categorize and manipulate data, that is, you change the data to your convenience, the process which is involved in it to extract the necessary information, that is called as data processing. So data processing is what? It is basically process of organizing, categorizing and manipulating data for what? For extracting information. Now, what are the various examples of techniques and procedures used in data processing information extraction, right? Now, these are the examples. First one is for recognition. Now, how do you do recognition? Recognition can be done through facial data classification. As in, you show your face and the data is processed. Now, for example, you would have seen when you walk into some of the offices, the punching machine generally has a facial data recognition. For that matter, you can even see the mobiles nowadays which have a face reading mechanism. So that is basically kind of data processing only. Now for processing stock market data, there is something called as time series analysis. This is one more example of data processing. What exactly is time series analysis? Time series analysis is nothing but it is basically a specific way of analyzing a sequence of data points. And these are collected at regular intervals, or rather which are collected at regular intervals. So what is time series analysis? It's basically a specific way of analyzing a sequence of data points which are collected at regular intervals. Now, where do you do that? You would have seen that when a weather reading is done, this kind of data is used. So basically these are used in things like weather data. You would have seen if you have to figure out some kind of sales, it can be annually, quarterly. In that case also you use a time series analysis, so to see how the business is actually performing. To see the stock prices, for that also you generally use time series analysis, and that's what we are talking about. And one more example can be that of interest rates, right? So these are various scenarios in which the data processing techniques and procedures are being used, right? Okay, let's move on. Now we need to know a bit of history of data processing. Now this is basically divided into three phases as per technological advancements, right? So initially it was started with something called as manual data processing. Now manual, as the word itself says, it was done without the help of machines, right? But it is still used in certain situations because it's not practical to digitize all the data, or if there is any inability the machines to read the old data. So if it's a very old data and the data cannot be fed into the system or can't be digitized, or if it is very difficult to digitize the data, in that case manual DP is still used. Example can be in case of retrieving data from outdated text or documents. You would have seen some companies would have a very old file, so it's difficult for them to be scanned. You know, the quality of paper would have gone down miserably. So the only option that you're left with is you can only keep that data in a manual form. So that is manual data processing. Then you come to something called as mechanical data processing. Now processes data using mechanical tools and technology. Please don't confuse it with modern computers, right? Mechanical DP is completely different from the modern computers. Example can be, this came in 1890 when a system was made up of intricate punch card machines, right? So basically some punch card machines were used. This is how a punch card machine used to look like. This was installed by US Bureau of Census. The purpose was to assist in compiling findings of national population census. So at that point in time, that is in 1890, when a population census was taken, in that case this tool was used, which was called as intricate punch card machine. So this is an example of mechanical DP. The use of mechanical DP is that it was easier and quicker to search data compared to manual DP, right? Because it was mechanical, hence it was relatively better than as compared to the manual one, right? Finally, we came on to, or as the generation progressed, we reached to a stage of electronic DP. Now, obviously, this replaced the earlier two, resulting in fall of mistakes, because when it is more electronic, the chances of mistakes are less, and also it increases the productivity. So that's the purpose of having electronic data processing units. Uses computers and other cutting edge technology. So computer is basically used in electronic DP. So please don't confuse. Mechanical DP doesn't use computers, whereas electronic DP does. So that's the difference between the both. Now, where exactly these are used? These are used in various industries, research institutions, and academics, right? So basically we have data processing divided into three phases as per technological advancement. First one is manual one, second one is mechanical one, and the third one is electronic one. Mechanical does not include the use of modern computers, whereas electronic does. So that's the core difference between both of them. In case of mechanical, please remember we talk about the punch card machines, right? Electronic DP was used to overcome the mistakes of the earlier two and to increase the productivity, generally used in industries, researchers, institutions, and academics, right? Now let's move on to the most important part of this chapter, that is how data processing and data science is relevant for finance, right? Because we all are finance professionals, so we exactly need to know how data processing and data science is useful for us. The simple way of remembering this can be this, because there are many points in this. So please remember this way, more easier for you to recollect. It's R square C cube, PPF and A cube. PPF, Public Provident Fund, maybe I thought that would be an easier way for you to remember. I generally remember it by R square C cube, PPF and A cube. These will all be in a series, right? So there is no jumbling of these as we move on to the topic. So you simply can remember it as R square C cube, PPF, A cube. So there are two cubes, one square, and PPF you can remember in between, right? So R square, C cube, PPF and A cube, right? Let's start with R square. First we'll start with risk analytics. So R for risk analytics. Okay, what is risk analytics? Techniques that measure and predict risk more accurately, right? So whenever the techniques which are used to measure and predict the risk accurately, for that we use something called as risk analytics. Now, business obviously involves a lot of risk, especially in financial industry, yes or no? Because whenever money is involved, it's a likely tendency that there may be high risk. So it is very crucial to determine risk factor before making any decision. For example, protection against cyber security risk. So there may be hacking of passwords or the systems, or there may be people may hack various systems or softwares. So that is a cyber security risk that we carry. So for that, risk analytics has to be done, and that's the core part of data processing. Risk analytics is important for defending the business, that is to protect the business, which is determined through data science, right? Then moving on, once the risk is identified, once you use that risk analytics mechanism to identify the risk or the danger, it shall be prioritized and its recurrence can be monitored closely, right? So once you know what exactly is the risk, then you prioritize it accordingly, and just to make sure that it doesn't repeat, you have to keep an eye on it so that it's not repeated or it is being monitored very closely, right? Then you talk about machine learning algorithms. Machine learning algorithms, they can analyze historical transactions, which eventually analyze customers' reliability and trustworthiness, which is vital to determine risk while lending. So when you have algorithms in place, as in you have various systems or mechanisms which capture the data of the earlier use of the customers, in that case it can help you to know the reliability and the trustworthiness of the consumer. This is very essential in terms of lending businesses. So unless and until you know the risk that a potential customer has, the lending becomes a bit difficult. So if you know what exactly is his reliability and trustworthiness, it's more easier for you to lend to the people so that you can recover it easily, and that will be profitable for business as well, right? Otherwise it can prove out to be an NPA, that is a non-performing asset. So you got to make sure that you lend it to the right person. So in that case, these machine learning algorithms plays a very vital role. Now the transaction data may be used to create dynamic real-time risk assessment model that immediately responds to new transaction or if there is any modification to client's data. So if you have a record of the transaction data, now this can be used to create a dynamic that is very I would say very proactive in nature, and something it also helps you to know what kind of risk assessment model it carries. so that if there is any new transaction, it can respond to it immediately, it can capture the data in future, if and it can do a good risk analysis of that, right? So the first thing that we talk about is risk analytics, right? Now moving on to the second one, that is R square. The second one is real time analytics. So first one we did was risk analytics. Now we talk about the real time analytics. Now real time is what? Whatever is happening at this point in time and you capture that, that is real time analytics, right? For example, a customer walks into your bank, whatever transaction he is doing at that point in time, so your system captures that. So that is basically a real time analytics. That's a simple definition of it. Now let's look at what the content is telling you. Discipline that applies logic and mathematics. So two things are applied in real time analytics. One is logical reasoning and one is mathematical reasoning, right? This discipline is applied where? This is applied to data to provide insights. For what? For making better decisions quickly, right? So basically you use logics and mathematics to what? To data in order to make better decisions, right? Now this real-time analytics basically are available in various forms. This can be in the form of data engineering, it can be in the form of data science, it can be in form of machine learning, or it can be in the form of business intelligence, right? So you can remember all these four. You need not get into nitty-gritties of it. Just an example, how does a real analytics work? So it can be form of engineering, data science, machine learning, and business intelligence. Now please remember, these all will work together so that they get a good user experience, right? At the same time, this will improve their experience also. At the same time, this will help you to know have a good grip and knowledge of the customers that are dealing with you, right? So that would help you to enhance your business in a better way. Then with the real-time analytics, there are no delays in establishing customers' word to an organization. So whatever is coming in, you are immediately capturing it. So in that case, the chances of delays actually get delayed, disappear. The delays get out of the picture, and that helps you to retain good customers and enhance your service in a better way. So something like credit ratings and transactions are more precise, right? Because you have real-time analytics. So the ratings that you give to your customers and the transaction, they are more accurate, right? Okay. Now we have finished with what? We have finished with R square. R square was what? R square, we talk about risk analytics and real-time analytics, right? So these are the two things you need to remember from our perspective. Then we talk about C cube. If you remember C cube, the first one is customer data management. Now the customer data management talks about what? It talks about the various strategy, tools, standards, and processes. So it talks about four things. One is strategy that you need to apply, the tools that are used, the standards that needs an application, and the processes that are brought into the picture that a business uses to manage customer data, right? So these are the four things for what they primarily are used for managing customer data, hence that is called as customer data management. There is a lot of data available, but they are more or less unstructured. Yes or no? You can have a lot of data, but that has to be in a structured form. If it is unstructured, it is very difficult for you to retrieve data whenever you need that. So methods such as text analytics, data mining, and natural language processing, these are used for what? These are basically used for data science is capable of dealing with mass volumes of such unstructured data. So in order to make this data more structured in nature, in that case what you can use is text analytics, data mining, and natural language processing. Okay, please understand what is natural language processing. It's nothing but it's basically a branch of computer science, right? It's a branch of computer science, or you can say in today's terms it is more a branch of artificial intelligence. Now what does natural language processing does is, natural language processing, it basically gives computers an ability to understand text and spoken words the way the human does, right? So the way we understand, the same way the computers also has an ability to understand text and spoken words. This is done through something called as NLP. NLP is what? That is natural language processing, right? So see, when we understand, it's a language processing. When a system does it, then it is a natural language processing because it is automated. So whenever a computer is able to understand text or the spoken words, the way the human does. In that case, it is called as an NLP, right? How does this help? This eventually leads to better understanding of market patterns and client behaviors. So the core principle of having a customer data management is to have a good understanding of the market patterns as to how the markets are working and how the clients are behaving, right? So these are the things that you got to remember. So the first one, I'm sorry, okay. So customer data management is nothing but the various strategies and tools, various strategies, tools, standards and processes that a business use for what? For managing customer data. Now there are various data that is available, but it is unstructured. So you use three methods or mechanisms. One is text analytics, one is data mining, and one is natural language processing. So that data science is able to deal with mass volumes of what? Unstructured data. How does this help? This helps in better understanding of market patterns and clients' behavior. What is natural language processing? It is nothing but it is a branch of computer science or artificial intelligence, and it basically gives a computer to understand text or the spoken words the way we humans do, right? So that is customer data management. Now we move on to the next one, which is called as consumer analytics. That's the second part of C. What is consumer analytics? Now, systematic examination of companies' customer information and behavior to identify, attract and retain the profitable customers. So consumer analytics says that whenever a company is using the information available to it and the company's behavior for what? For identifying, attracting and retaining the profitable customers. That is called as consumer analytics. Now it is important to ensure that each customer receives customized service. Yes or no? If the service is personalized, it's more likely that you can retain the customer. And because it is done through a system, it can save a lot of time for you. So it says it is important to ensure that each customer receives customized service without time consuming individualized analysis. So you don't have to go to particular customer per se. Whatever data is being captured, the same can be used to all the customers in order to make customized service. More or less, this will be applicable to everyone, but if there is something which is very specific to an individual customer, you can make sure that those preferences are also taken into consideration, and hence you can actually improve their performance, or you can improve their service towards that particular client, right? Now you can take an example of insurance firms. What does insurance firm does? Insurance firm basically use the real-time analytics, something which we read before, along with prior data patterns and quick analysis, eliminating sub-zero customers, right? So we need, insurance firms generally need the customers who pay their premium on time, right? So they don't need someone who default on their premiums, right? So they can keep a track of that. That's why they are called as sub-zero customers. This eventually helps in what? If you capture such kind of customers and you retain them, in that case, that can help you in cross-selling new products, and at the same time it can have a lifetime worth of a consumer. So that's how consumer analytics plays such a pivotal role, right? So what is consumer analytics? It's basically an examination of customers' information and the behavior for what? For identifying, attracting and retaining profitable customers. Now it is very important to ensure that each customer gets what? A customized service, but this can be done without even consuming time on individualized analysis. Example, that can be of a insurance firms, right? Okay, now we move on to the third part of C, that is customer segmentation, right? So what is customer segmentation? Segmentation simply means division, right? So they are segmented on basis of what? They are segmented on basis of various socio-economic factors. Now what are these factors? It can be based on your geography, age, or it can be your buying patterns, right? So these are the various ways of segmenting a customer. Now segmentation basically helps you in eliminating clients who provide little value and focus on promising ones. So your concentration can be, because you do a proper segmentation, you can make sure that you pick up those customers who are very profitable to you, rather than concentrating on people who don't add much value to your business, right? So data scientists can basically use algorithms to use such data to categorize clients based on specific attributes. Now you can see there are high value net worth customers, right? Or what we called as, or something like high net worth individuals or NRI customers. Because they bring a lot of business, you can concentrate on that. That doesn't mean you ignore the other ones, but your focus can be more on them, because since they bring in more business or more revenue, in that case your concentration can be on them. So that is called as customer segmentation, focusing on customers who give you more profitable ventures than the ones who are not so profitable, right? This data can help the business to know the time spent with each client, right? So customer segmentation will help you to know how much time you're spending on each customer. Now, if you just remember, if you know, there's something called as a Pareto analysis, right? Now, what does Pareto analysis says is, Pareto analysis is basically an 80-20 rule. It says that 20% of anything, if you concentrate on 20% of the most the priority, in that case that will solve the 80% of your problems, right? Now you would have seen that even if you study your syllabus, if you concentrate on 20% of your syllabus, maybe that will be the major chunk of your entire syllabus. Same it works in the business also. If you concentrate on the first top 20% of the customers, they will bring you the 80% of the business. So that is basically 80-20 rule. That is the Pareto analysis that we talk about. Similarly is the case with customer segmentation also, right? So what we have read till now is R square. R square talks about the risk analytics and real-time analytics. Then we spoke about C cube. C cube is customer data management, consumer analytics, and the third one is customer segmentation, right? Now we come to what? Something called as PPF, right? Now PPF talks about what? Okay, I have A in between, so we can skip this and we can come back to it later. Okay, first we talk about the first P of PPF. First P talks about the personalized service. Okay, what is personalized service? It plays a very vital role in enhancing customers' reputation, right? If you give a personalized service to someone, obviously that will help you to improve your reputation in from customers' perspective, and it also increases customer lifetime value, right? Because the customer stays with you a longer period of time, so that automatically increases their value also, right? How it is applicable to financial services? Now, for example, there are things like telephone interactions, right? You can have person-to-person conversation, so that gives you most personalized service. You also have something called as natural language processing. That's something we read before, as in the computers or the AI, they can speak in the same way, or they can understand the text or spoken words in the same way as the human does, right? So if you give a personalized service in form of telephone interactions or NLP or voice recognition technologies, you would have heard something called as an IVR. IVR is what? IVR is basically interactive voice response. You would have seen whenever you call to any kind of customer care, in that case there will be a automated system which would recognize your telephone number, and they would start responding to you accordingly. Now, for example, if it's a mobile, if you want to know a mobile balance, in that case you simply call a mobile service operator, Airtel or a Vodafone. You just dial in your number, and whatever data balance or whatever phone balance that you need to check, that can be done through an IVR. Now again, that's kind of a personalized service. No human is involved, but that has a lot of value, right? So whenever you have to give a personalized service, these three things will add to it. It can be in the form of telephone interactions, natural language processing, or voice recognition technologies. Now it helps to know the customer needs, and it also facilitates cross-sellings. Yes or no? Because if you have direct interaction with them, you would get to know what exactly they need, and finally you will also know what all products can be sold to them. Leave A right now, we'll come back to this. We'll finish that PPF first. The second one we talk about is predictive analysis. Now it helps to extrapolate from existing data and predict future as to how patterns may evolve. Right? What is extrapolate? Extrapolate is nothing but if application of something unknown situation by assuming that the present trends will continue. Right? So if you estimate something through whatever data is available to you, that means extrapolating something. So you can extrapolate from existing data and predict future based on the patterns, right? Now more information improves the prediction model. The more information that you have, you can make more precise predictions. Now deep insights of information helps to establish rules and attain superior performance, right? So if you have deep insight or the deep understanding of the information, that will help you to establish what rules and attain superior performance. Now an example of predictive analysis can be what? In case of stock market, machine learning algorithms learns from past data. Yes or no? Whenever there is an algorithm, they will pick up data from the past, and it helps in forecasting the future stock market trends, right? For example, you pick up any stock for that matter, say it is an ITC stock, right? So previously it has been trading in a range of say 200 or 250. Now suddenly there was a spike and it became 450. Now this is a trend that the system will catch up. So in future, if the same pattern follows, in that case, this predictive analysis can be very handy. So that's what it is talking about. Now this helps user in making investment decisions and future trading strategies. Yes or no? If it's a trader, then they will get to know how does the pattern work, and they can do intraday or positional trading according to it. And if it's an investment decisions based on the price pattern, they can make the investments accordingly, right? Okay. The next one we talk about in PPF is fraud detection. So F for fraud, right? Now, why fraud detection is so important in data processing? Artificial intelligence and machine learning algorithms can detect credit card frauds more precisely. Why? Due to vast amount of data available and its ability to respond to real-time suspect behavior. Right? So why fraud protection is so important, and how does data processing helps in fraud detection? Basically, if you use something like artificial intelligence or the machine learning algorithms, they can detect credit card frauds. Otherwise, there can be huge loss to the company as well as the client. So in that case, data processing plays a very pivotal role. Now, for example, how does this mechanism work? If a bulk purchase is made on credit card, right, for a customer who's traditionally frugal as in he doesn't spend much of an amount, right, and there is a huge transaction that has happened. In that case, the card will be immediately terminated, right? So its use will be stopped and a notification can be sent to the card owner. So that's how a fraud detection is done. Example can be that of a credit card. This eventually does what? It helps eventually to protect the client and helps in maintaining a good reputation of the bank, right? So if you are able to detect the fraud at the right point in time, obviously that protects the client and it also helps you to maintain good reputation of yourself, right? Now we come to the last three, that is AQ. So AQ, first we talk about the advanced customer service. Now what is advanced customer service? Data science has an ability to give customized service. Yes or no? Since interaction with customer is real time, effective recommendations can be given to manage specific customer's case. So because you have all the data with you, you already have collected all the information. In that case, if there is any specific need of the customer, that can be catered to. NLP, please remember, NLP is very, very important. You can use NLP in most of the examples, in most of the points over here. This can be very, very handy. So please understand what exactly is NLP. NLP, as I said, and I'll just reiterate, it's basically a system based or an artificial intelligence which can read or understand the text or the spoken words in the same way the humans can, right? So that is what is NLP. Now NLP can offer practical financial advice based on the interaction. Yes or no? So whatever interaction has been there, NLP can code it and then decode it for you. This can be used for cross-selling of other products, right? Everything that we do eventually is to what? Cross-sell and to increase our business and the profitability of the business. So that's what we are supposed to do, right? Then each customer interaction that can be used for subsequent interactions of similar nature, eventually enhancing the efficacy. Efficacy is what? It's basically the performance of the system. So every interaction that is being done, they can be used for the subsequent interaction which are very similar in nature. What it does is it eventually improves the performance of the system. So that what is advanced customer service. Now we come to the second last part, that is called as anomaly detection. What is anomaly? Anomaly is nothing but basically deviation from the standard or something, of if there is any discrepancy or difference from the actuals. So that is called as anomaly detection. Now, data analytics can discover instances of unlawful insider trading. Okay, what do you mean by insider trading? You would have read it in law also. Insider trading is nothing but when the stocks, generally it is spoken from a stock price point of view, you know that something good or bad is going to happen in the company, and before public knowing about it, you as an insider knows about the in and outs, right? As an event, eventually what you do is you buy or sell the stock just to take the undue advantage of the information that you have. So that is called as insider trading, very much unlawful. SEBI has completely banned it. So data analytics, what it can do it's basically they can discover unlawful insider trading before they cause a substantial harm, right? Now what are the various ways of anomaly detection? It can be done through a recurrent neural network or long short-term memory model. Please remember this, just for information purpose, what is recurrent neural network is? It's basically an artificial network. It is nothing but it is an artificial network. What artificial network which generally uses time series data, right? We've already read about time series data. If you just remember, we spoke about the stock prices analysis, or if you remember in the first when we spoke about data processing also, we read about the weather data and the interest rates and the stock prices. That's what is time series data is. So basically recurrent neutral network is nothing but it is an artificial network that uses time series data. Long short memory models, you can remember this as LSTM, right? This LSTM is a kind of recurrent neutral network. That's it. You don't have to go into nitty-gritties of it. Just remember, if you talk about anomaly detection, it's basically nothing but whenever data analytics use unlawful discover instances for unlawful insider trading. In that case, this comes very handy. What are the various methods of anomaly detection? It can be done through recurrent neutral networks, or it can be done through LSTM, that is long short memory models. LSTM is nothing but it is again a kind of recurrent neutral network, right? Okay, these algorithms can analyze the behavior of traders before and after information about stock markets becomes public. Why? Because just to make sure that it was not a part of insider information, these algorithms basically can analyze the pattern of the stock prices, right? If there is any undue advantage taken of investors by illegally monopolizing the stock, right? So basically, if any operator has manipulated the stock just by knowing the insider information, in that case, this anomaly detection comes very handy. Now, how do they catch them? They catch them through two mechanisms. One is recurrent neutral network, or through long short-term memory models, right? So this is more than sufficient for you to remember about anomaly detection, right? Okay. We move on to the last part of this, that is algorithmic trading. That is AQ, the last part. Algorithmic trading is nothing but it talks about the system that utilizes advanced mathematical models. So this primarily focuses on mathematical models. For what? For making transaction decisions in the stock markets, right? If you know something about trading in the stock markets, you would have seen that the intraday traders or a positional trader, someone who does futures and option, they generally use algorithmic trading nowadays. They would have read the past data, and on the basis of that, the system would analyze the stock prices accordingly, and the buying and selling will be done to make more profit, right? So that's what is algorithmic trading all about. It basically eliminates the risk of loss caused by indecision and human error. Human generally tend to make error. Now algorithmic trading doesn't do that because it has data from behind. Then in that case it can act accordingly, right? Doesn't mean it's error free, but yes, it increases the chances of your profits more, right? So that's why algorithmic trading has so much of relevance. Now also there is a mechanism where agents are self-trained on rewards and punishment mechanisms, right? So whosoever is these trading agents are, they are trained on rewards and punishment mechanisms. Rewards here talks about the profits, and punishments is basically the loss that you do in a trading, right? So this algorithmic trading has a mechanism wherein the agents, they automatically self-train them on the basis of rewards and punishment mechanism. This process is called as reinforcement learning, right? So whenever there is a mechanism where agents are self-trained on rewards and punishment mechanisms, that is called as something called as reinforcement learning, right? Each time a transaction turns out to be a poor option, this model helps the algorithm to learn and adapts it accordingly so that it doesn't repeat the same mistake again, right? So what is the advantage of this? Increased frequency of deals based on data computer can react in seconds. So you can have more data, you can have more transactions within intraday happening if you are a trader. So you can make more deals, and you can earn more profit, and the machine will trade only if it receives profit opportunity as per the rule set, as per the algorithm. So whatever has been the algorithm, machine will read it, and if it sees an opportunity wherein it can make profit, it would act accordingly. If it thinks it's a loss-making venture, then maybe it will quit out of it, right? So let's quickly revise this important point because I'm again reiterating, very very important from exam perspective. So if you just remember all these headings and and a bit of explanation with example, that would be more than handy for you to score good marks in this, right? Okay, let's start. How do you remember this? We remember this by saying R square, C cube, PPF and A cube. Let's start with R square. R square is what? It talks about risk analytics and the First one is risk analytics, and it talks about the real-time analytics. Then we talk about C cube. C cube is customer data management, consumer analytics, and customer segmentation, right? Then we talk about PPF. PPF is personalized service, predictive analysis, and fraud detection. And finally, we talk about A cube, that is advanced customer service, anomaly detection, and finally we talk about the algorithmic rating, right? So that's all about 9.1, guys. If you really like this channel, do subscribe to it. Please like and share with your friends who are learning the same thing. And in next time we will come up with 9.2. We will study 9.2, that is function of data processing, and we'll just move on with business data analytics. And if you have not seen the coverage on chapter 8, all the modules of chapter 8 have been covered already, so please watch that also, and learn good and happy learning. Thank you.